Let's just jump straight into it, shall we? Welcome to the Explainer. Today, we're unpacking a tool that is, honestly, a bit of a game changer. It's called Schemalyser. Look, if you're a data engineer or an enterprise architect, you already know the pain of untangling a massive legacy database schema you didn't build. It's a colossal headache, right? It usually involves way too much coffee, a lot of guesswork, and massive blind spots. Well, Schemalyser tackles this by using a fully local, deterministic AI pipeline to analyze schemas, and it does it under an incredibly strict multi-agent governance framework. We're going to explore how this dual-plane architecture not only analyzes data securely, but kind of fundamentally rethinks how we build and govern AI agents.
Okay, so here's our roadmap for today. We'll kick off with the data egress dilemma, look at deterministic pipeline efficiency, and walk through a schema classification. After that, we'll cover setting up local environments, dive into multi-agent contract governance, and wrap up with audit-ready data reasoning.
Right. Section 1. The data egress dilemma. Analyzing schemas securely.
So picture this. You've got this sprawling legacy schema, and you want to use a large language model to help classify the tables. Figure out which ones are core facts, which are lookups, junction tables, the whole shebang. Normally, you'd have to fire off your database metadata to an external cloud provider. But here's the million-dollar question. How do you analyze enterprise schemas without risking data egress? For most strict enterprise environments, sending your structural metadata out to the public internet is literally a non-starter. It's just an unacceptable security risk.
And honestly, relying on those external AI services, it creates two massive headaches. First, obviously the egress risk we just talked about. But second, these external models are essentially non-deterministic black boxes. You ask them to classify a schema today, you get one JSON output. Ask again tomorrow, you might get a slightly different structure. They return completely inconsistent structural analysis. And if you're orchestrating a massive source-to-target enterprise migration, you absolutely cannot build your strategy on fluctuating AI outputs. You need strict, repeatable, audit-ready reasoning, which perfectly sets up the need for a closed local system.
Which brings us to Section 2, Deterministic Pipeline Efficiency, the runtime engine.
Now just look at the stark contrast here. Over on the right, the non-deterministic external AI approach. It gives you unpredictable variance, high egress risk, and really weak guarantees on the actual shape of the data it returns. But on the left, Schemalyser's deterministic local pipeline. This runs entirely on your local CPU. Zero data egress risk because literally nothing leaves your machine. It relies on strict JSON output contracts, meaning the shape of the data is enforced by hard code, not by crossing your fingers and hoping the AI plays nice. And the absolute best part? It guarantees byte-identical reproducibility.
The key to all of this working is this number right here, 0. In Schemalyser's configuration, the AI model's temperature is set to exactly 0. But it doesn't just stop there. By pairing a 0 temperature with a fixed random seed, pinned thread placement, and a fixed Python hash seed, this pipeline mathematically guarantees the exact same JSON response every single time you feed it a specific schema payload. It essentially forces a probabilistic AI to act as a fully deterministic function.
Moving on to Section 3, Schema Classification Walkthrough, from metadata to insight.
Let's see how this actually works in practice because the sequence is just beautifully orchestrated. Step 1. You post your schema metadata payload, your tables, columns, foreign keys, straight to the local fast API service. Step 2. Deterministic Python tools step in to pre-process this verbose dictionary. They extract the primary and foreign keys and squash them down into this highly efficient table signature. Step 3. That compact signature is handed off to a small, local language model which infers the structural roles. And finally, Step 4. The output is forced through a strict pydantic JSON validation layer. The system physically cannot return malformed data. The pydantic contract, using extra equals forbid, will instantly block and reject any random, unexpected fields the AI might try to hallucinate.
So what actual insights do you get out of this? Well, the validated JSON gives you exactly what you need for migration planning. It gives you inferred table roles, specifically flagging lookups versus junctions. It maps those tables to inferred business domains. It explicitly defines your hard-coded primary and foreign keys. And crucially, it infers hidden relationships and targets that might not even be formally enforced in that messy legacy database. Having this precise, contract-validated structural schema analysis just massively improves your migration accuracy.
All right, Section 4, Setting up Local Environments. CPU-only deployment.
This perfectly highlights how accessible this local infrastructure really is for data engineers. You do not need a massive server rack or some eye-wateringly expensive GPU for this. The deployment is brilliantly simple. Step 1, Just create a standard Python virtual environment. Step 2, download a small local model, specifically the QN2.5 1.5 billion parameter instruct model in GGUF format, which is heavily optimized for standard processors. And step 3, you run the entire analysis on your CPU using the Llamically tool under the hood. There are no external API keys, no GPU memory limits. It is a completely self-contained offline environment.
Which brings us to Section 5, Multi-Agent Contract Governance. I like to call this the meta layer.
So we're shifting gears slightly here, from the software itself to how the software is actually built. This repository uses a really fascinating multi-agent framework. Instead of a chaotic, free-for-all codebase, Schemalyser's evolution is governed by generic agent roles. You've got a governance or planner agent that authors precise markdown-based iteration contracts. Then a coding agent implements the code to meet that exact contract, nothing more, nothing less. After that, an auditor agent jumps in to check compliance and aggressively block any scope drift. And finally, the human in the loop acts as the ultimate product owner, injecting priorities and approving the overall direction. It's a brilliant way to ensure the codebase never deviates from those core structural governance standards.
You can see how every single feature follows this strict project roadmap. It acts like an append-only, contract-driven loop. First, the human injects a priority request. Second, the governance agent translates that into a hard contract with clear acceptance criteria. Third, the implementer writes the code and runs the verification tests. Fourth, the auditor checks for scope drift and rigorously enforces the rules. And fifth, the human reviews the release and approves the cycle. This methodology guarantees that the tool analyzing your data is built with the exact same deterministic rigor as the analyses it spits out.
Let's pull this all together in our final segment. Section 6, Audit-Ready Data Reasoning. Repeatability as a contract.
The core philosophy driving all of this is beautifully captured here. Every output is gated through pydantic validated contracts, and the runtime is engineered for byte-identical reproducibility. You see, reproducibility here isn't just some nice-to-have feature. It is a foundational contract. In an enterprise environment, if you can't audit and reproduce exactly why an AI made a structural decision about your data, well, you frankly can't use that AI.
So what are the big takeaways from this explainer? We've seen that Schemalyser provides a complete elimination of data egress risk simply because it stays entirely within your walls. It offers high-efficiency, CPU-only local execution, making it incredibly accessible to deploy. The project itself is built on a strict multi-agent governance framework that effectively eliminates scope drift. The runtime delivers reproducible, byte-identical JSON outputs. And when you combine all of that, it gives enterprise architects a uniquely reliable foundation for planning those incredibly complex source-to-target schema migrations.
I want to leave you with this final, slightly provocative thought as we wrap up today. When you're staring down your next massive data migration, and you're relying on either slow manual mapping or highly variable external AI, ask yourself, are your schema migrations built on hope, or are they built on hard contracts? Thank you so much for joining me for this explainer. Until next time, stay curious.